Sine of negative 150 degrees.
Festive Winter Holiday Light Edition.
Right, without a calculator. So let's draw ourselves a picture.
Always draw a picture.
Here's our quadrants and a negative 150 degrees. So 0 is here. Negative 90 would be here.
Going the other way. Going the other way this time.
Negative 180 would be here. So how far past 90 do we have to go to get to 150?
60 degrees.
60 degrees, which means we'll have 30 left over. So 60 degrees past negative 90. It is kind of helpful. Like normally I don't make a big deal about like drawing to scale because I feel like it, stunts my creativity. But with 30, 60, 90 triangles, it is kind of helpful.
It's a little bit on the beneficial side to have those
bit.
Angles halfway close to what they're supposed to be.
Yeah, because then it's really easy to tell since we went 60 this way. Okay,
That's got to be 30, right?
Right here. And we went negative 150 to get there. So.
Hey, I think you connected that terminal side of the angle to the x-axis. Am I correct?
I did, and that's what we always do.
You didn't connect it to the y-axis.
No, we never want to connect to the
double
y.
check.
Always go up or down to the x-axis.
Right.
And so across from 30 degrees is 1, which, hey, that looks like the smaller side. It's negative 1 since it's going down.
Right.
The hypotenuse is 2. Got negative square root of 3 over here. And
how did you know that was a 1 that went down like that?
Because it's a special right triangle, 30, 60, 90. 1 square root of 3, 2. The 1 is always across from 30 because our angles like match up and stuff. The smallest angle is across from the smallest side. Thanks. I don't know if that was a compliment to me or to math. I'm going to say you complimented both of us.
At one time.
We both appreciate it.
Okay.
All right, sine is opposite over hypotenuse or y over r, depending on how you want to think of it.
Get comfortable with y over r, kids.
So negative 1/2 is sine of negative 150 without a calculator.
Wow, you're a genius.
Thanks. Okay, so let's
4
do
pi over 3.
4 pi over 3. Now we're getting into this like, I was going to use the line drawer thing and then I forgot.
Yeah, that's okay. But that's a fairly straight line if you can ignore the squiggles.
I thought it was pretty good.
Yep.
Okay, 0 degrees is over here. But I didn't mean to put degrees.
Not
We're
degrees.
in radians.
We're 0.
Okay, but it's not a big deal since they're both 0.
Right.
Pi is over there.
Yes, pi right there. There's a pi.
Pi halves.
Pi halves.
1/2 pi is better to think of it.
And then 3 halves pi.
What you need to think of is it's 1 pi to get from here to here. And so if we're talking about thirds of pi, like we end up with being able to like break this up into thirds, that kind of thing.
Right.
Which those aren't quite to scale, but like that's what we're talking about whenever we look at 4 thirds pi. We're trying to go more than 1 pi.
More than 1. How much past 1 pi are we going?
Well, I believe we're going 1
1/3 past pi?
Yes, because 4 thirds is 3 thirds plus 1/3.
That is amazing.
So we're going 1/3 past
so
pi.
we're 1/3 past pi.
And so that's going to be about right here.
That is excellent.
Okay, and the sooner that you can get the hang of like, it is helpful to think of what this is in degrees, like at least as far as the reference angle goes. If there's a 3 on the bottom, our reference angle is going to be 60 degrees because 3 times 60 is 180.
Shut the front door.
All about that conversion of pi and 180 and all that stuff. So
that's a genius trick.
This is 60 right here inside of our triangle.
Well, how can you tell if it's
there.
a 30-degree reference angle of what's on the bottom?
Well, if it has a 6 on the bottom, then it should be a 30-degree reference angle.
Why?
Because 6 times 30 is 180.
That is insane.
Yeah, or, really logical depending on, So this is a 30, 60, 90 triangle, so we've got our sides here just like up above.
Wow, exactly the same.
It's turned. Because
the hypotenuse, though, stays the same.
Yeah, the hypotenuse stays the same, but now we're talking about 60 degrees instead of 30.
30 degrees.
And tangent is opposite over adjacent, so that's negative square root of 3 over 1. I'm sorry, y over x is what I meant to say.
Y over x.
And that gives us, they're both negative, that gives us positive square root of 3.
Bingo, bango, bongo.
Okay, secant of negative 5 pi over 4.
You had me at secant.
Secant. Why did I have you at secant?
Look at that word. How fun is that?
I like that as
it's
a word.
It's a fun word.
It's a neat word,
yeah,
I guess, as far as words go.
Yeah.
All right, so let's think about where negative 5 pi over 4 is.
Secant.
That sounds kind of negative when you say it like that. I prefer to see can. No, like I see that we can do this.
I see that too.
Okay, so negative 5/4.
Okay, now hold on. I'm going to try. Okay, let's see. 5 pi over 4. That's going to be 1 pi over 4 spot past 4 pi over 4.
Right, because negative or 5/4 is 1 and 1/4.
Yes.
Yes, and we're going in the negative direction. So we are
Going upside down.
We're going 1, and then we're going a fourth of the way past it.
1/4 past the pi.
This is half, so this is a fourth right here in this quadrant, right here, over here, and it's. I mean that's
1/4. So 4 pi over 4 plus pi over 4 is 5 pi over 4.
You can't really tell, but that's a 45 degrees. So again, 4 times 45 is what gives us 180. So every time there's a 4 on the bottom, our reference angle is going to be 45
That's crazy.
degrees. Or really helpful. I mean, it's whatever. -1, +1, and the square root of 2. Remember the hypotenuse is always positive.
Right. Always.
We both agreed separately that that's the case.
I don't know why you would bring up stuff like that.
I don't know.
I was clearly right at one time.
Yeah. You were.
So the secant then of this is going to be the reciprocal of the cosine, which happens to be x over r.
So we want r over x.
R over x it is.
So square root of 2 over -1, which is negative square root of 2.
Blam! Look at that.
Perfect.
Trig functions, no calculators.